Okay, and good morning. Or good morning. Yeah, it's morning. It's 8:15 in the morning. So thank you for being here, and I'm so happy to be here, of course. And let's see, what have I been working on? So I've been working on writing a paper. I want to write a paper, like a version of the Killing Primes story that I wrote, like write it as an actual paper to submit. And I don't know if I would like to work with some people on it, but I'm not sure. I'm not sure if I'm going to, but I definitely I'd be interested in working with people, but if I'm working by myself, and I'm just gonna forge right ahead. So yeah, so so this week I've been like, I was like, okay, every day this week I have to do like a little piece of the paper, do like a section. So by the end of it I have like 15 pages, but it's mostly it's copied from the other paper, like it's in the way that was written, most of it. So but at least it's there, and so I feel like not next week I have some plans, but then the week after that I'm gonna um do a like really rewrite it, like really make it like a paper. Okay, and so I feel like, what I made a recording earlier and I was talking about this. It didn't work out, but like I was trying to do it on Substack, but I couldn't share. I still have the problem of sharing. It's probably honestly my iPad, because that's all I'm using. But what I was talking about is that a lot of times it feels like in math, when you're writing a math paper, it's like a lot of times you're recopying. You're just recopying and retyping, because there's like the moment when it happens, like the glory, when you have some idea and you're writing it down, like maybe this stuff I was doing. And in the moment, in the glory moment, it feels like, oh, this is like everybody knows this. This is very straightforward. This is like this makes sense. I don't even need to write this down. This is easy, So, but I feel like in the glory, looking back later, I'm like, what were you doing? Like, what are you doing? Like, how did you come up with that? So write down the glory, and then later, it's just recopying it and recopying and retyping it and recopying it and rewording it. But it's sort of done after that. And I keep thinking like, oh, I gotta write this paper. It's like, I gotta write this paper. I gotta work on this paper today. But it's like, it's already written. It's already done. So I'm really just recopying. But yeah, it's easy to think that like what's happening in the glory is really straightforward and will last forever. But later, it's like, oh, it's very good that I wrote that down or whatever. So I'm just talking about how productive I am. No, it's like it's actually working pretty well. This system that I've got going. I can't every single week just like write every day and like get up and write, like, because it's very exhausting. I know like other people have a lot going on, but I feel like if I write for 2 hours in math, I'm completely exhausted for the day. So but it's been going well this week. So I want to share with you, I was going to share a little bit about just show you the paper that I was working on. And then also I made an app. I guess this would be like, I made an app a long, long time ago. And I suppose this would be my third app, and I am using the AI to help me. And it's very fun. And I don't know if anybody likes it, but I think it's very cool. So I think you guys should just like it just a little bit more. Just get into it. Okay. Okay, so the first thing, I just want to show you the paper that I was working on. Okay. Yeah, my hair is kind of interesting because like as I get older, it kind of changes. It's interesting. So I was kind of looking at that. Okay, let's look at the paper. And I'm just gonna put the like recording over it. Okay, I've tried to find other ways to share, but okay. Okay, so here we go. So I'm gonna just go through. Okay, Aaron, you can put up the screen of the paper that I'm writing. Okay, so a lot of this is it's kind of challenging because the way I wrote it was like a story, and so now I have to write it more like more boring, no, more professional or something, or more mathematical. But I think I am going to use these little objects, and just the main idea is that in M we see what happens when we pause or mute the creative ability of a number. And I really think that this kind of research has like taken off. Like there's a lot to do with this. Okay, so we talk about, in the first part, I'm just going to scrolling. I'm on page 2 now. And we can just see the 3 block and the 4 block. We get in the 4 structure we can make from the 2 blocks, and then we're going to need a 5 block, and then the 6, there's 2 structures. Okay, so, and then I have these pictures, which I'll try and make the pictures more like, professional. Math paper like, because that's like, it's a whole different art form. And it's like a very like austere art form. and I like it. Okay. So arithmetic in M. Okay, so the arithmetic, this part, it's just like, I don't even know if I need to do this. That's why I do feel like I wish I had some other people involved in this, because I don't really know, like, do we need this? Do, you know, I mean, I'm saying that giving a process for how I'm on page 4 now. I'm giving a process for how they add and multiply numbers, so that you get a structure that's back in M again. So I'm not sure if we need to do that, but okay, I think it's fun though. I think it's fun that you don't have to count. Like, you don't really have to like count the individual blocks in this world in order to add. You really just have to know what the prime blocks are. Okay. And in this world, like, the only prime blocks exist. Like, if you put 2 blocks together, it'll make a stack. But if you put 4 blocks together, if you're in the regular M, it won't like stick together. Okay, I'm on page 5 now, and I'm just looking at multiplying 3 block by the 5 block. Okay, and then let's go on to the killing prime. So the page 6, or just the killing prime sections. Okay, so here we start talking about what does it really mean to have. I like this idea that these blocks are too unstable to create, you know, and it's like they're very creative, but if you're creative, you know, all mathematicians are creative, you know that if you're not stable somehow, then you might not be as good at being creative. And that's kind of like the idea. It's like not stable, so it's not creative. Now, I don't know. Erdos, was he stable? I don't know. But this is just like a little fun idea. Okay, yeah, I don't know. Do you create more math when you're like unstable or stable? I definitely see some times in my life when I'm like, let's say I'm up here in this very, very small town. I'm like, I'm a little bit bored. So like I do a little more math. So I definitely find that there might have been some times in my life where things were a little bit chaotic or something, but the math was stabilizing. So anyway, okay. So what happens when the 2 can't be used as a prime base? Okay, so we go into killing primes and what happens, and like how 4 becomes a prime block now, and then the 6 structure, there's only one of them when you miss the 2. And then we have the theorems about if you kill a prime p, then p squared becomes prime, but all the other, and it's preservation theorem, all the other prime numbers are preserved, and there's no other new primes, and we're going to need this later. Okay, what if we kill more than one prime? We see that we see this pattern that if you kill a set with n many primes, then there's 2 to the n minus 1 many new primes. We get some nice combinatorics in there. Okay, so we're on page 8 here. We see this. We're looking at m to the minus p, so this is of great interest. This is the world where we kill all of our primes. And then from there, when I started doing this work, so I'm going on to the next page, the degrees. If you kill all those primes, then you go to m to the minus p, and then you kill all those primes. Then you have the next rank of primes. So this inspired me to have this idea of degrees of prime degrees. So every natural number has a prime degree. If you're 0 and 1 have degree 0. If you're prime, you have degree 1. And if you're next up, if all the primes in your prime decomposition are killed, like, when do you step up and be a prime? So like if 4 is going to be a prime, if we kill all of our primes, 4 is a degree 2 prime, because if you kill all the rank 1s, 4 is definitely going to be a prime. And maybe there's a way to think there's only 4 only has rank 1s in front of it. Anyway, you can kill all the primes, but you can also like kill individual. You can kill all the primes in front of some other prime, and it'll become prime. You can also kill all the primes of that rank. But I think it's a nice way to describe, to give a ranking to degrees. I think it's natural, and I think that it's nice because it's not, it doesn't go up as the primes get bigger. No matter how big of a prime you are, your degree is still 1, and I think that's really nice. The composites, the degrees will go up naturally as the composites get bigger, but they'll go up and down. But if you have more in your prime, if you have more powers of primes in your prime decomposition, then you're going to have like a higher degree. Okay. So the rank of a natural number n is k if n is of the form p to the k. So if it's a power k prime, power k of a prime, or if it's a non-prime and there is no p to the k in its prime factorization, but there is a p to the k minus 1. Okay, and this is nicely just organizes the numbers. Okay, and then you can see this image on the next page of this is the degrees. The primes are in red, the next degree is orange, yellow. The rainbow that I used for all these was red, orange, yellow, green, blue, pink, and then purple. Just I didn't want to get the blues mixed up together. Okay, then the next thing was Riemann zeta in extensions of M. I really liked this section. It really kind of had a lot in it that I didn't realize at first. And so I just wanted to see, and this is the main idea of this kind of work, is like, what is, take the basic things of, or whatever, take some things from number theory, and just say what does it look like in these worlds. Okay, so if I wanted to look at what's the product of 1 over 1 minus p to the minus s, that product, if we take not the primes in M, but the primes in M to the minus p, or M to the minus 2. Okay, so you can see we do this math, and I'm going to go into the next page because I see we're kind of getting, we're running out of time. There's plenty of time, but my computer can't hold that much. Okay, so we do this exact same, it's the proof from the Euler showed that this product is equal to this sum. This infinite product is equal to this infinite sum, and in the end we see that in M to the minus 2, if we take the product of the primes, then we get the Riemann zeta function divided by, with a little remainder, 1 plus 1 over 2 to the s, and 2 to the s was the prime that we killed, so it doesn't get filtered out. And so in general, if we kill a prime q, then the zeta function for that world is the zeta function divided by 1 plus 1 over q squared, a q to the s. And if you actually divide that out, it's the sum 1 over n to the s, where n is just not a multiple. The things that remain in over there are the multiples of q. Okay. And so then we keep going to the next page, and eventually we can see that that if we kill all the primes, and we look at the product of the primes in M to the minus p, 1 over 1 minus p to the minus s, we get the prime zeta function, divided by 1 plus zeta function divided by 1 plus the prime zeta function. You can take this even further and say, well, what if I take all the degree 2, that's the same, m to the minus p is all the same as the degree 2 primes are now prime. So if we take the product of all the degree 2 primes, we get this product 1 over 1 minus p to the minus s, we get the zeta function divided by 1 plus the sum, this infinite sum, but now the denominators are all the degree 1 primes, so all of our primes, just like we just showed. So if you want to know what's the product, if you take the degree k primes, 1 over 1 minus p to the minus s, it's the zeta function divided by 1 plus the sums 1 over p to the s, where the p's are the degree less than k primes. It just reminds me so much of my thesis. Okay, it just reminds me so much of my thesis, the like feeling of it, not the actual math really, but just the feeling of it, like, you know, the degrees up to this level and then the degrees at this level. I think that's really nice. Does anyone think that that's a good application or something that they might find useful? I hope so. Okay, then finally the applications, then I'm talking about like, once we get accustomed to these newer worlds, we might ask bigger questions. Is Goldbach's conjecture true in any of these worlds? Can we make it true by traveling to a new world? Is the twin prime conjecture true in any of these worlds? Let us start to explore the consequences of killing primes. Okay, so then I do the thing about Mersenne primes. You can kill n many primes and get a prime number of new primes. We talk about twin prime conjecture. We talk about Goldbach's conjecture. So does Chen's theorem plus killing primes solve Goldbach's conjecture? No, probably not. But, you know, is this a way to start thinking about it? What would it look like to show Goldbach's conjecture is independent, therefore true? What would that look like? And so basically I said, you know, I get a little, you can look at this. Sometimes I say things that are a little extreme. But I'm in the intent of having fun. So I just was saying, Gödel, Cohen, and many others have shown that there's a great variety of mathematical worlds, the great variety in mathematical worlds, and one can change large cardinal attributes through forcing. Should the finite numbers be any different? Are there models of arithmetic with different sets of primes? Is killing primes the way to plow ahead and solve some of the problems of the past and the future? Oh, okay. But yeah, you know, a lot of people believe that there's some flexibility in the finite realm, and this isn't even really finite realm. It's, you know, this infinite set of natural numbers that are so amazing in the primes. Okay, so I hope you like that. Okay, the next thing I want to show you, this is getting kind of long today, but I wanted to show you guys so badly my app that I made. Oh man. Okay, so I'm gonna show you my app. So here's the app. Let me just clean up my phone a little bit. Hi Zeke. Zeke's right over there. Here's the app. Okay, so what's our range of numbers? I like to pick really random ones. So like I'm gonna do 444 to 555. Okay, and then all this scroll appears of all the numbers. And how many prime degrees would you like to explore? I'd say let's just do 7. You can do as many as you want. And I'm just gonna add them. So let's do degree 1 because we want to see the primes. And once you see degree 1, you can even stop there if you want. And you can see all the degrees. Okay, and then let's just do 2, 3, let's do 5. I don't know, let's do I like to do random things. 7, 11, let's just do primes. 1 isn't prime. Okay, 13. Let's just see. Okay, so then it's going to highlight all the colors, and it tells you in the box what the colors are. And you can see when they get bigger, it's like just like the other stuff I was doing in the book about like coloring the numbers, the natural numbers. We're using that same idea. So like 1 is red, and then when you get to 8, that's also red but has a 1 stripe. 11 is green with a 1 stripe. Okay, etc. Okay, so here's our picture, and the best part is you can listen to it. So I can't wait for people to start making music with this. Oh, it's so good. I get obsessed with it. It's fun. It's really fun. So I hope you enjoy that. Come on, you guys. Don't you like that? Don't you like what I made for you? Just joking, you guys. You know, I have so much fun. Okay, so thanks so much for listening, and I'll see you next time. Let me know if you have any ideas. If anyone, someone said something about really killing primes. If you have anything and you have some ideas for this, send me an email because I'd be happy to collaborate or talk about or anything. You know, if you have some ideas, the paper's in the works. So if you want to get into it. Okay, it's so nice being here. So nice talking to you guys. I will see you. I'm going to plan on, I don't know for sure. I was changing my schedule, but I'm going to plan on, at least this summer. By the way, big plans, big changes coming. But I'm going to plan on Fridays, do a math in the morning and share with you what I've got so far. Okay, but let me know if there's anything you want to see or anything. Okay, glad to talk to you, and I hope you have a great day of mathematics and enjoy weather if it's nice spring for you. And I'll see you soon.